Okay, in this video we're going to talk about complex numbers, a plus bi, where a is your real number and bi, I being the imaginary part. Okay, so we're going to talk about how to add these, subtract these, multiply these, and divide these using the conjugate in this video. So first example, adding complex numbers. You have the first complex number, 4 plus 2i, plus the second complex number, 3 minus 4i. Now the one thing to remember is an answer to a complex problem has to be a complex answer. So a real part and an imaginary part. So let's watch and see how this happens. Notice they always have parentheses around a complex number. So in front of parentheses we know there's an understood 1 and an understood 1. So to get rid of these parentheses, we're just going to distribute the 1s. Now we're not foiling, but we're distributing a 1. So 1 times 4, 4. 1 times 2i, positive 2i. 1 times 3, positive 3. 1 times negative 4i is a negative 4i. Once we get here, we can combine like terms. We've got 3, 4, and 3. Those are real numbers. We can add 4 and 3 to get 7. And then notice we have 2i and a negative 4i. 2 minus 4i is going to be a negative 2i. We have a real part and an imaginary part. We can't combine them. That's your answer, a complex answer to a complex problem. Okay? Now, I know a lot of people don't like the understood ones here and distributing those out. It doesn't really matter with addition. But with subtraction, it has a huge impact. Let me show you how that is. Right here. We have an understood 1 in front of this parenthesis, but over here it's not a 1 anymore. It's a negative 1. That's going to have an impact on that right side. 1 times 4 gives me 4. 1 times 2i is still a positive 2i, but over here things are going to change a little bit. Negative 1 times 3 is a negative 3. Negative 1 times negative 4 makes that a positive 4i now. So very important to watch that distribution. Now you still combine like terms. 4 and negative 3 are real. You can combine them. 4 minus 3 is a 1. 2i and 4i are imaginary. You can combine those. 2i plus 4i makes a positive 6i. That's your complex answer to a complex problem. Let's multiply. Now, multiplying is your FOIL method. You're distributing twice. I know I'm multiplying because there's not a plus sign in between my two parentheses, or a minus sign for that matter. So I know I have to multiply. So you're going to take your 4 and multiply with your 3 and your negative 4i. So let's do that first. 4 times 3 is 12. 4 times a negative 4i, that's a negative 16i. That's your first distribution. Your second is with your second number of 2i. 2i and 3 and 2i negative 4. So 2i times 3, that's a positive 6i. 2i times negative 4i. Well, 2 and negative 4 multiplied is negative 8. I times I, you add exponents to get I squared. Okay? Now, every single algebra teacher will tell you, you got to combine your like terms right here. So you're going to have 12. Negative 16i plus 6i. Well, negative 16 plus 6 is a negative 10i minus 8i squared. Okay? And then we got to take care of that 8i squared. You got 12 minus 10i minus 8 times I squared, which we should know I squared is a negative 1. If you don't know that, I'll show you in a minute where that comes from. Let's finish this problem up first. 12 minus 10i, negative 8 times negative 1 makes a positive 8, which turns this into a real number, which is very important, because now we have 12 and 8, which are both real. 12 plus 8 makes 20 minus 10i, and that's the answer to this multiplication complex problem. Let's talk about the I squared for a second, though. Got to make sure you understand where the I squared comes from. Hopefully your teacher has taught you that I is radical negative 1. That's the imaginary number. That's a very basic one, okay? I squared means you're going to have radical negative 1 times radical negative 1. Well, That means radical negative 1 times radical negative 1. A rule in math is if you times a radical by itself, the radical goes away and you're left with what's on the inside, so you get I squared to be equivalent to a negative 1. Okay? Let me prove this piece to you right here, because sometimes kids don't understand or they kind of question where it comes from. Let's say you have radical 3 times radical 3. Well, if you multiply that, you're going to get a radical. 3 times 3 is 9. But what do you know about radical 9? Radical 9 is 3. So that's why we can always go ahead and jump that middle step. A radical times itself is always a number on the inside, which is why radical negative 1 times radical negative 1 is just simply going to be negative 1. Okay. Let's jump on to division. Now, division is a little bit more complicated than this adding and subtracting, but if you can do the multiplication, that's pretty much what this is. You're just going to do it twice, okay? So notice this says divide with a conjugate. Okay, a conjugate means you're going to change the sign of the imaginary number. So if we're going to divide these two complex numbers out, you're actually going to divide by multiplying the numerator and denominator by the conjugate of just your denominator. So if I have 3 minus 4i, my conjugate's going to be 3 plus 4i. Well, if I multiply my denominator by 3 plus 4i, I better multiply my numerator by 3 plus 4i, just so it can be mathematically equivalent. Now, I prefer to go back and put parentheses on here, just so it makes more sense that I'm going to FOIL, which again is just distribute twice. I'm going to FOIL my numerator. Then I'm going to FOIL my denominator. So let's distribute twice. 4 times 3, 12. 4 times 4i, that's 16i. 2i times 3, that's 6i. 2i times 4i, that's 8i squared. Same exact thing, but with your denominator now. 3 times 3, 9. 3 times 4i, 12i. Negative 4i times 3 is a negative 12i. Negative 4i and 4i is a negative 16i squared. So we've done basically the same thing we just did in the last example. We multiplied our numerator and our denominator. Let's continue. Let's combine our like terms here. And let's go ahead and replace the I squared with what we know. I squared is a negative 1. So it looks like this. 12 plus 16i and 6i, well, that makes 22i. Plus 8 times, instead of I squared, we just talked about it. That's negative 1. The exact same thing in your denominator, but this is going to be nicer. Your 9 comes down. What happens with 12i minus 12i? That cancels. That goes away. That's the reason why you just did what you did. You want that to go away. So this is going to be eliminated. You're left with minus 16 times I squared, but that I squared we know is a negative 1. So close to being finished. Continue. 12 plus 22i. 8 times negative 1 becomes a negative 8 now. All over 9 minus 16 times negative 1. Well, 9 and negative 16 and negative 1 make a positive 16. Almost finished. Combine your real. 12 and negative 8 are real. What is 12 and negative 8? Well, that's going to be 4 plus 22i all over 9 plus 16, which is 25. This is your answer to a complex division problem. Notice you still have a complex answer in your numerator, but your denominator can't be complex. It's a rule. You can't have a complex answer in your denominator. That's the whole reason for doing this whole process. You're rationalizing a denominator. This would be your answer. Okay? Study these and go back and try some on your own.